Hello everybody and welcome to today's webinar, which is getting started with LinkIt 7687 HDK on how to prototype power efficient IoT devices with secure Wi-Fi connectivity. My name is Michael Francis and I look after some of the marketing here at MediaTek Labs. Today's presenter is Philip Handschin, who is a technical consultant at MediaTek Labs. So with no further ado, I'm now going to hand you over to Phil, who will talk to you all about the LinkIt 7687 HDK.
Thank you, Michael, and good morning, good afternoon, and good evening to everyone. I'm very happy that you joined this morning, and I hope I can give you a good insight into our new RTOS development platform. So today I'm going to show you how to get started with the MediaTek LinkIt Development Platform. Let's get started. So at the beginning, like just a few minutes, what MediaTek Labs is, what we're all about, how we can help you. Just kind of an overview of MediaTek Labs. Then we are looking at the LinkIt Development Platform for RTOS. So a general overview of the platform and what it's aimed at, what it can do. And then we come to the meat of this webinar. It's how to get started. So installing the SDK, compiling a test project, then preparing the board. Today we look at the 7687 board. So prepare the board for flashing, using the flash tool, and then obviously checking if the flash was successful, so connecting to the board, seeing the logs coming out. And then in the very end, we create our own project. So this will give you a very good start into using the 7687 board. And as Michael already said, we will answer all the questions at the end. So this is the overview. Let's have a look at what MediaTek Labs is all about. So we here at MediaTek Labs want to help you. That's kind of our aim. It's a completely free global program. So we have people all around the world supporting developers like you. Best thing is to go to labs.mediatek.com. There you will find a wealth of information. We have different HDKs. We have software development kits. We have a forum where we answer all technical questions, but also business questions. So definitely check out our labs website. There you have a lot of information. Our aim is to enable you to kind of go from an idea to a prototype to a product in very simple steps and with a lot of support from our side. So, you know, the prototype is based on our HDKs. So on our website, you can find the right HDK for you. We have quite a few now, different ones for different projects. And you also find the according software development kit for that for Arduino, but then we have also more professional software development kits for C, which you can use in Eclipse. We also have a board that runs OpenWRT on it. So there's quite a wealth of different HDKs and software development kits. But further than that, like once you have your prototype, we also help you with maybe matchmaking. So if you want to know what is a good prototyping house or who can mass produce now my prototype, we're very happy to help that, like on a business support side of things. So please check the website and get in touch. We can help with any question. So here is a quick overview of the HDKs we have so far. So the LinkIt one is more aimed at wearables, LinkIt Assist as well, the 2502. Then we have the LinkIt Connect, which is a low-level Wi-Fi enabling kind of smart home application. And then we have like the LinkIt Smart 7688, which is an open source Wi-Fi platform. That's the one that runs OpenWRT, very powerful processor on there. And then we have today's one, the 7687, where we look at that in a minute. We have a huge developer community. So just go to like hacks.io or Instructables. You will find loads of different projects, and we're always amazed by the creativity of our community and what they come up with. So it's worth checking that out as well. Right. So let's have a quick introduction on the RTOS platform we just launched. So we started off with the MT7687F, which is a Wi-Fi system on chip. Is our core business is chips. So this was the easy part. We then kind of found the right operating system to run on this chip. So we chose the free RTOS operating system, which is the de facto standard for embedded devices. It is open source and has a huge community supporting it, so it was a perfect match for us to use that operating system. Furthermore, we needed then to make it really easy to kind of develop your own things on top of that operating system. So we created our an SDK and tools you can use to compile your projects and debug and generally kind of create an exciting device. And last but not least, we created an HDK with our partner SAC. So you now are able to purchase like a 7687 HDK from our website. And the kind of applications we envisage are based on 7687 are kind of connected home appliances like air conditioning units or washing machines, but it could also smart gadgets like drones or light bulbs or anything that needs kind of Wi-Fi enabling. And then you can connect it like through your broadband router to the cloud and control it via your smartphone, as an example. Right, so this is kind of like setting the scene. So now I will talk to you through how to get started with our SDK and our 7687 HDK. So first thing first, we look at how to install our SDK. So to begin with, you should go to our labs.mediatek.com website and go to the LinkIt for RTOS SDK introduction. There you will find 2 downloads, and you should download the IAR and GCC because today we're looking at the GCC implementation, so a completely free toolchain you can use on your Windows computer. But we also provide a toolchain for Linux. But on today's webinar, we look at the Windows implementation. So download that and store it somewhere you know where it is. We can find it later because first we need to install something else. So we install the MinGW, which is a cross compiler. You can find it on the following link. So you download that one and you start the installation process. So you'll see a lovely screen like this one. You click install. There's another one where you have to choose the path. So you just click continue. I would recommend to use the standard path, and all the whole webinar is based on the standard path. So we kind of need to copy some files around. So it makes it easier to follow if you kind of leave the default path there. On the next screen, you will see you have to install some additional packages. So there are 2 you have to select. So that's the MinGW32 base and the MSys base. So you have to both check the box so that they get installed. And then you have to select the installation menu on the top left and then click apply changes. Once you do that, all the packages will be downloaded and installed. So you just have to apply the changes you just made, and then they kind of start downloading and it should get installed. Once you successfully done that, you should have a folder, a MinGW folder, And on the mysys and 1.0 folder, you will find a file called mysys.bat. And if you double click that, you should start a terminal, which is like the one you see on the screen below. So if that is working, then you successfully installed the MinGW compiler. So you can close it again. And we can now move on to copying the SDK into the MinGW folder. So early on, you downloaded the SDK file. So you would have to unzip the downloaded SDK file and copy the whole folder. So something will be something like LinkIt HDK version 331. So the whole folder you have to copy on the MinGW mysys 1.0 home and then your username, and then just copy the unzipped file in there. So once you've done that, we can move on to install the ARM GCC. So we need an extra GCC for compiling for our ARM processor. So you have to download the ARM GCC Win32. Again, please go to that link, download the zip file, and then unzip it. And the unzipped folder, you have to copy again under the MinGW mysys 1.0 home username, and then you have like the SDK root we just kind of copied in there. And under the SDK root, you will find a tools folder and also a GCC folder. So you just copy it into the GCC folder. But before you copy it, you have to create a Windows, like a Win folder. So on the GCC, you create a folder Win, and then you unzip the whole content of the ARM GCC into that Win folder. And after you unzipped it, you name it GCC ARM non-EABI. So this was a lot of copying stuff around. Now you should have a file structure looking something like this. So you have MinGW installation directory. Then under this you have the mysys folder, and on the mysys you have 1.0. Then you have home. Then you have your username, which in my case is MTK09225. Then you have the LinkIt SDK, so the downloaded LinkIt SDK, you kind of completely unzipped it into this folder. Under the LinkIt SDK, you have a tools folder. In the tools folder, you have a GCC folder. There you created a Windows folder, Win, and under that you unzipped the GCC ARM compiler, which is GCC ARM non-EABI. So you have this folder structure. Good. Okay, let's move on. To kind of test our installation, we will now compile a test project. The wonderful thing about our SDK is that it contains lots of demo application which showcase like the different capabilities of the board, like Wi-Fi connectivity, like HTTP clients, but also I2C connectivity, etc. So it's well worth kind of looking through all these different projects, because you can then base the project onto these. You can create your own project based on these demo applications. So let me show you now how to kind of test your installation. So again, we navigate to the MinGW mysys 1.0 folder, and we launch a terminal by running mysys.bat. So let me go into, so this is now my installation, as you can see, and I have like the mysys 1.0, and I have the MySysBat. I double click that, and I have now like the console up and running. And now we kind of list the content of this folder. So the only thing we have in here is our SDK. So we change directory into our SDK folder. And in here you have different files and folders, but like the most important one is the build.sh. So let's execute the build.sh, and with the parameter list, you will see all the projects that are currently available for building. This is a very useful tool, and it will also show you like an overview of all the currently available demo projects. So we see now it's calculating the MT7687 projects. So there's quite a few of them, as you can see. All these projects are already included in the SDK and are ready for you to use. As I said, like you have HTTP clients, you have I2C ones, you have an IoT SDK demo, which kind of combines a lot of these features into each other. We have like infrared kind of demo projects. So there's a wealth of code already available. So now, just to kind of check if all the GCC compilers and everything is working correctly, we can just choose one. So I would say the HTTP client get, and we can just build that one. For building, again, you use the build.sh script, and then you have to, the parameters are, first is the platform you want to use. So in our case, it's as the MT7687 HDK, and then you have the project you want to compile. So it's HTTP client get. So let's go to our console and we enter MT7687 underscore HDK. And then we want to project HTTP client get. We hit enter and it will start the compiling process and will give us output on what it's doing. And this will take now like a minute or two to kind of compile the whole project. And after that, it will dump all the files you need to flash the tool in an out directory. In this out directory, you find all the logs as well. So now we just have to wait for a minute till kind of this process is completed. So you see, it's a very straightforward. Once you installed it, you can easily use this for any project and start building your own projects. How to set up your own project, I will come to that later on in the webinar. Next thing we will be looking at is like the out directory. So once the compilation is successful, the out files, you can find them in your SDK root. There's an out directory. And again, you will have the HDKs, so the MT7687, and then you have the project name you just compiled. So it's still building, but we can already go to that folder. So as you see, we have here is the SDK root directory, and we have an out folder. We have MT7687 HDK. And then HTTP client get. So the folder was already created, and now all the files will be dumped in there once the build was successful. As a tip, you see there are already log files building in there, coming in there. So you see like more and more files are getting copied over the more it gets built. If there are errors during your build, is there compilation problems, then you can have a look at error.log. There you will find useful information on what exactly went wrong. Yeah, to kind of debug then your compilation process. We're nearly there. There we go. Copying firmware. Ta-da! So now we compiled our first project, and we will find like now all the files in this folder. So the flash download ini, that's kind of like the file you need to kind of load then into the flash tool. So we created now all the files. Right. So once we have a project ready, once we have all the files, we need to kind of flash the board. We need a board to flash it. So we connect our 7687 board with the micro USB cable to our computer. And you will need to install the drivers. And you will find the drivers on the given URL there. So it's an embed driver. And once you install the driver in your device manager, you should see a new port, which is the embed 0 port, and this is our board. So that's all you need to do to prepare the board to make it ready. So now it's about time to flash the board. There's a jumper, the jumper 25, which defines the flash mode the board is in. So every time you flash it, you need to set the jumper. So to connect the 2 pins, as it is shown in this picture. And so you unplug the board, you set the jumper, and then you plug the board back in, and then it boots up into flash mode, so it can actually be flashed. The next thing is to get the flash tool ready. So the flash tool is again in the SDK root on the tools, but it's still packed up in a zip file. So you have to unzip the PC tool win file, and in there you will find a MT7687 flash tool. And under there you have a Windows folder, and in there you will find the MT76X7 flash tool exe. So if you double click that, a screen like this should be shown. So let me show that in the real world. So again, on the SDK root in tools, you have this PC tool Windows zip folder. In there you find the MT7687 flash tool public. So, and then under the Windows folder, you have the MT7687 flash tool exe. So now we can open that one, and the screen looks like this. So what we have to do is to select the download scatter file. So this is the flash download ini we just created when we compiled the project. So we go to our SDK root out directory, our MT7687, and then we have the HDB client, and then we have here the flash download ini. We can open that, and then it kind of loads in all the bootloader and like our project files as well. And please make sure you unclick the format whole flash, so we only have the download scatter file activated. Then we have to select the correct COM port. So we click refresh, so all the COM ports are listed. There we go. We have the COM port 63. The speed is correct. It's correct. Like there's 92,1600. Yes, and once we kind of selected all this, and we connected the board with the jumper setting in flash mode, we can press start, and the computer will detect the board, and the board will be flashed with the firmware we just created. Again, this will take a few seconds. But after that, your board is all ready to go. Let's have a, there we go. Great stuff. So this is how you flash the board. Pretty straightforward, very easy to use. So again, click refresh if you can't see like your COM port, select the right COM port and select the correct speed, and then just press start. So yeah, you load the flash download, you select and you click start and off you go. Now to run the project, so we have to disconnect the micro USB cable from the board. We then set the jumper like back into normal mode, and we reconnect the board with the micro USB cable, and we press the reset button to start the board up. And then we can use Hybrid Terminal or PuTTY to see what's going on, to see the log files. So let me show you that. So I use PuTTY, and as before, we have like the COM port 63. So here you have to choose a serial connection, COM port 63. The speed is 150,200. And then we open the connection. And because now it already loaded the whole program, so we have to press the reset button again, and you basically see the startup sequence. Great. So we just compiled our first project, and oh, sorry, I just disconnected the board. So we compiled our first project and we successfully flashed the board. So you see, once all the tools are installed, it's a pretty straightforward, pretty easy process. Again, that's like in PuTTY, you have to create a serial connection with the correct COM port and then open the connection. Right, so how do we create a new project? Easiest thing to do is to copy an existing project. So we choose like what kind of project is kind of very similar to ours. And then we have to change the makefile in the GCC folder. And then we have to change the code, obviously, to kind of suit our needs. And then we have to compile the project. So I will give you a demo on that as well. So for my needs, I will go to projects 7687, and so it's actually good to know we have like two folders on the projects. One is hardware access layer examples. So there you see like all the projects kind of related to the hardware access layer. So you have I2C, I2S. You have different like SPI. You have all the different technologies from the hardware access layer. And then also the other one, you have the apps, which are then kind of like more of an application, like where you use multiple of these technologies together. So you have an HTTP client, and on the day you have get, keep alive, and retrieve. So like different sort of projects. So it's well worth having a look at different projects and see which one is suitable for you, or which one you want to use to kind of base your project on. So for me, I'm taking I just want to do like a GET request, HTTP GET request to a server. So I want to connect to a Wi-Fi network and then just see the response from like a simple GET request to a web service. So what I do, I'll copy this project into the apps folder. And then I'll kind of rename it to like webinar client. Okay, so we've done that. On the webinar client, we have now the same, like the GCC. In there, you'll find the make file and all the other files we need for creating the compiling the project. And then on the SRC folder, you have like the source. So first thing we need to do is to change the make file. So you open the make file in your preferred editor. So I'm using Visual Studio here. You can use whatever you like. So we have to open the make file. And in here, we have to change the path of the project. So here we have the name. So we have to change that now to webinar client. And here we have the path to the project. So we have it directly on the apps. So it's just apps webinar client. And because this project was kind of in a subfolder, the source directory is actually like one higher up. So we have to adjust that as well. So we save that, and now our project is already ready for compilation, but we haven't really changed anything in the source code itself, so it's exactly the same project. So let's go and change some of the source code. So in the main, you have like the main functions of the project, and in here, I just want to show you. Actually, I'm not going to change anything. So we have an URL we will request, and then we will just print out the result of this request, this GET request, onto our console. So this is an API where it shows you basically the longitude and latitude of an IP address. But we also need to change the Wi-Fi settings. So we go into SDA network C, and in here we have the Wi-Fi SSID and the Wi-Fi password. So the Wi-Fi SSID we will change to webinar, and the Wi-Fi password we change to password. This is set up on my mobile phone, so the board will then connect to my mobile hotspot once we kind of run it on the device itself. Right, so we save this, and we save on a domain we don't have to save, so we can close that. And yeah, this is it. We already have the webinar client ready. And if we now go into our console and we do the build sh and then the list again, we will see now that we have an extra project, the webinar client. As you can see, now we have an additional project underneath the MT7687 HDK. All the previous ones are still there, but now we have an additional one, the webinar client. So this is a good way to check that you kind of changed all the make files correctly. And now we can go about and compile it. So again, we select our HDK platform, and then we choose our project. We hit enter, and it will start building the project and create all the files we need to flash the board. There you go. It starts. And again, this will probably take like a minute or so. Right, so we see still building. So the next thing will be to kind of, again, use the flash tool to flash the board, and then see if the board can connect to the Wi-Fi network and print out the GET request result. So let's have a look how far we are. Still compiling. But as I said before, one really good tip is to always check the out directory. We probably already have it yet. There you have the error log and the build log. So if anything goes wrong during your compilation process, please check these two files. They will give very useful insights into what went wrong and how you can fix it. And as I mentioned before, like this webinar now focuses on the Windows tools, and the exactly same tools are available for Linux. So you get a GCC compiler for Linux. You can compile on there. Yes. Okay. It's all looking very good. And linking, yeah, great. Okay, so this should take only a few seconds more. So in the meantime, I already disconnect my board again. I set the jumper again to flash mode, so jumper 25, and I plug it back in. And now I can go to my flash tool. And I can select my files. So I have now my webinar client, and I choose the flash download again. I refresh, and I see like the COM is now 56. Okay. And I start flashing the board. Also get then PuTTY ready for the connection, so we can then see like the result coming back from the HTTP GET request. So it will be a simple JSON object that will be coming back. There we go. Flash was successful. Now we have to disconnect it again, remove the jumper, and connect it again. And then we can connect with PuTTY to the board. So it's now 56, and we open the connection, and there we go. We can start from the beginning, but here you already see the result of the get request. So we get like this lovely JSON object back with longitude and latitude where this IP is from. Well, let me reset the board. So this is the normal boot up process, but then you also see like how it connects to Wi-Fi. So there you see like we got just connecting to Wi-Fi, and then it executes the HTTP request and we get the result. So as I said, if a build fails, it's very good to have a look at the out directory. In the project log folder, you get like all the details why. But there's also a much more detailed instruction on how to get debug up and running in our Getting Started guide. So please go to our labs website and download all the documentation. It's very extensive and it's very good. Okay. Yeah, we just checked the logs in our Hyper terminal. Again, you connect it. Yes, but now I think we open the floor for questions. Michael, do we have any questions from the attendees?
Thank you, Phil, for a very interesting overview of the 7687 HDK there. That was very insightful. The moment we don't have any questions in the WebEx panel, but if anybody does have any questions at all, please do type them in now, and we would be very happy to answer them. So if you just go to your WebEx panel, you can either put them in the chat or the Q&A. It's entirely up to you.
While we're waiting for some questions, I want to highlight our next webinar Michael is hosting. So it will be State of IoT Nation, and it will be a panel discussion on like IoT in general. Michael, do you want to?
Excellent. Thanks, Phil. So we have a question. Thank you very much. And it's, do we have MQTT client support?
Yes. I would have to double check if there's already a demo project, but yes, that should be supported.
Thank you, Phil, and thank you for the question. We have another question, thank you, which is, what is the difference between 7688 and 7687? I'm assuming we're talking about the HDKs there.
Sorry, the difference between the 7688 and 87, right? Okay, the 88 is a much more powerful chip. It runs a full Linux system on it, so it's OpenWRT. Whereas the 87 is a real-time operating system, so it's less powerful, less power consumption, so you can do less things but more power efficiently.
Great, thank you. We have another one. Do we have HTTPS support as well? That was in relation to the MQTT client support question.
Yes, it is. It's supported on the platform.
Thank you, Phil. Another one is, can we use free RTOS for commercial applications when using the 7687 base design?
Absolutely. That's our whole intention is as free RTOS is already used in a wide variety of commercial products. So it's very stable, very secure. And that was our intention, that people use this HDK to then go into production based on our SDK and based on our board, so based on free RTOS. So absolutely.
Thanks, Phil. We have another question. Are there any demos that shows how to change the STA settings? From this demo, we saw the change was made via source code.
So the question is to change the STA settings like not programmatically or with an app. So there are various different applications. You could also create maybe a you can set the set the board in AP mode, and you can connect with an app and then set the settings like this. So there are various different ways of how you could set the SDA settings, not programmatically, but like from a user, like based on a smartphone. Yeah, absolutely.
Thank you, Phil. We have another one. Is what is the debugger IDE used?
Well, we have integration for Keel and IAR, and then we also have like a toolchain kind of a Windows toolchain where you kind of have it in command line.
Thanks, Phil. We have another one. Can we have over-the-air / wire flashing on the go?
Yes, it is possible to have photo, so firmware updates over the air. That's also described in the SDK. So it's very well worth kind of downloading the whole package. And under the docs folder, you find a wealth of information about the board and also about the different aspects of programming, including firmware updates over the air.
Thanks, Phil. So that's all the questions we have now. We got another one regarding the use of, can we use Python apart from C?
Unfortunately not, no. As I said, it's a real-time operating system. It's a ARM Cortex-M4 chip, so it's really an embedded system, which doesn't have the kind of the power to run Python scripts, and yeah, so it's just C.
Thanks, Phil. So we've got another question from Kieran Kumar is asking, can we share the material with you? So absolutely, we'll put the slides on SlideShare, and we'll also put the recording of the live event on YouTube, and we'll email you with links when they're available.
Okay, so I think we're getting to a close. I just want to say thank you for attending this webinar, and thank you for your very interesting questions. And please feel free to send us emails for more questions. The best thing to do really is to go to the forum. It's monitored on a daily basis. So just if you have any further questions, please get in touch through the forum. Thank you very much from my side.
Thank you very much, Phil. This was really excellent, and thank you again, everybody. So if you want any more information, please go to labs.mediatek.com, where you'll find a wealth of technical tutorials, videos, how-tos, etc., and also details of our next webinars. So thank you very much, and enjoy the rest of your day.